Welcome back. In our last session, we discussed the ninth waste, information latency. We talked about moving data at the speed of light to ensure decisions happen as close to the event as possible. But today, we have to address a much deeper problem. Speed is a liability if data itself is a lie. In the asset intelligence framework, we operate under a strict protocol called information integrity. In the world of AI and high-end analytics, there is a fundamental law: garbage in, garbage out. If your source data is wrong, every calculation, every AI prediction, and every maintenance schedule that follows is a fantasy. Today, we are going to learn how to establish ground truth in your facility. We aren't just looking for data, we are looking for the truth. Information integrity isn't a vague concept. It is a technical requirement. In the AIF, we verify the integrity of every data stream across three specific pillars. Physical integrity. This starts at the sensor level. If a temperature probe is uncalibrated and reads 80 degrees when the asset is actually at 95 degrees, your intelligence is blind. In an AIF-compliant plant, every sensor is treated as an asset. It has a documented calibration life cycle and a health score of its own. No calibration means no integrity. Contextual integrity. Data without context is just noise. If a vibration sensor spikes, it is because a bearing is failing, or is it because the machine was in a startup phase with a different load profile? Integrity requires that we marry the sensor reading with the state of the asset. Without knowing what the machine was doing when the data was captured, the data is useless for analysis. Temporal integrity. This is where the human element often fails. This is about the truth of the timeline. If a technician performs an inspection at 10 a.m. but doesn't log it until 4 p.m., or if they pencil whip the log to show a check was done when it wasn't, the timeline is corrupted. In the AIF, we minimize manual entry and use automated timestamps and digital verification at the point of work to ensure the record is an honest reflection of history. Just like physical assets, data can suffer from forced deterioration. This happens when systems are poorly maintained, when communication protocols are patched together, or when staff aren't trained on the importance of data accuracy. When you lose information integrity, you lose the ability to perform root cause physics. You find yourself fixing problems that don't exist, while the real physical threats remain hidden in the noise. To build an intelligent operation, you must first audit your data streams. If you can't prove a data point is true, you must discard it. It is better to have no data than to make $1 million decision based on a lie. Let's look at a model case in a high-pressure utility environment. The team was seeing recurring overpressure alerts on a secondary line. They were preparing to spend $80,000 to replace a bypass valve they thought was failing. The AIF audit. Before approving the CapEx, we performed an information integrity check. We pulled the calibration records for the pressure transducers. The discovery? We found that the primary sensor hadn't been calibrated in 3 years. When we tested it against a master gauge, it was drifting, reporting a 15% higher pressure than reality. The result? The valve was fine. The physics of the system were perfect. The only failure was the integrity of the signal. The numbers? We saved the $80,000 replacement cost and fixed the issue with a $400 calibration. That is the power of ground truth. Your homework for today: go to your most critical asset. Pick one sensor or manual log entry from yesterday. Can you prove with 100% certainty that it represents the physical truth of the machine? If the answer is no, your first task isn't to fix the asset. It's to fix the integrity of the data. Now that we have established a foundation of truth, we can finally move to the commercial engine of the business. In the next session, we discuss the distorts engine. I'll see you there.